Today we're going to talk about how to measure and classify angles and how to find measures of angles in pictures based on other given information. So the first thing I want to do is talk about what an angle actually is. Now most of us have seen an angle before, but the formal definition of an angle is the union of two rays that share a common endpoint. So for example, ray ED and ray EC both share E. So when that happens, we actually have an angle that's formed. So in order to name this angle, there's four methods we can use. The first one is using three letters. And the only rule is the vertex, that would be the point they have in common, has to be in the middle. So angle CED could be a name for this angle. You could also go reverse order to angle DEC. You could instead name it angle 3 because there's a number in here. And that's probably the best way to name an angle. It's the safest way to name an angle so that you don't have to use three letters. So even if there's an angle that's given to you, you could always put a number in it and name it by that number. The last way is you can name an angle by its vertex, but you have to be careful about that. In this case, it would be okay because there's only one angle E possible. But if I were to do this, we'll call that B and I'll put a 4 here. If I were to do this and you wanted to name angle 3, angle E, that wouldn't be okay because there are actually three different angle E's. There's angle BEC that has E as a vertex, or angle BED. So in that case, one letter is not okay because it doesn't clarify which angle is being referenced to. Some of these definitions I'm sure that you've heard before, but we need to go back and just refresh your memories. Acute means less than 90, so angles that have a measure of less than 90. And they could look like that. They could look like that. And that. We'll do 3 examples for each. Then we have right angles, and those are angles that are exactly 90 degrees. And they are indicated by a small box. So we want to be careful about drawing right angles because this is going to probably be a new concept. It used to be that you would look at it and say, yeah, that looks like it's 90 degrees. But in reality, that could be 89.99 degrees, which is not 90. That's actually an acute angle, but it looks like 90. So we have to look for this little symbol. That symbol means it is exactly 90 degrees. So if you draw a right angle, it must have the small box in it. Or if you're deciding that an angle is 90 degrees, if it doesn't have the box, it's not 90. So there you can see some angles. And then we have obtuse angles. Now, usually people say obtuse just means more than 90. That's not true. Obtuse angles are angles that are between 90 and 180, not including 90 and 180. So from 90.00001 to 179.999, those would be obtuse angles. So if we were to draw some obtuse angles, this is what they would look like. They could look like they are just over 90 degrees. And then we have what's called a straight angle, and basically a straight angle is just a line. So an example of a straight angle would just be, that's not a very straight line, but that's okay. I'll call it AEC. So angle AEC is a straight angle because it makes a line. and it could be vertical as well. So we then have the word congruent. We've talked about that word before. Congruent means the same. So it's the geometry term for same. And congruent angles are angles that are the same measure. So there's a couple things we have to discuss here. These markings in here are called arcs. Just like when we had segments, I'll put it right down here. When we had these segment symbols, and if you saw tick marks on them, that meant, oh, they have to be the same length. Each side has to be the same length because they each have one tick mark. It works the same way with these arcs. So the fact that each of these has an arc, has one arc, I know that they are definitely congruent. In this case, they're both apparently 38 degrees. And so I have two ways of showing that. I can write the measure of angle ABC is equal to the measure of angle EFD. Or you can say angle ABC is congruent to angle EFD. That's how we read these two lines. It's just saying that the measures of the angles are the same. Now, if I had a picture that looked like this, and I put one arc in here and two arcs in here, you cannot say that these are the same because this has one arc and this has two. So that just means, hey, they're two different measures. We have a postulate that's called the angle addition postulate. And we won't get caught up in the formality of what the postulate actually says. We're just going to kind of blow through it. Basically, if you add two side-by-side angles, if you add those two measures, you get the whole thing. So if I was turning from A to B, and let's say I turned 30 degrees, and then I turn a little bit more from B to C, and so that's, let's say, about 10 degrees. Then if I just decided I'm going to turn from A to C initially, it would be 30 plus 10 and make 40. So we can say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle AOC. Again, it's like piece plus piece equals whole distance. So let's look at an example where we'll do an obtuse angle this time. And we'll say this is 40 degrees in here. And we'll say the whole thing is 100. Well, I wouldn't add 40 and 100 and set it equal to this angle. That wouldn't make any sense. Part of the distance traveled is 40 degrees. We don't know the rest of the distance traveled, but we know the whole thing is 100 degrees. So if I want to find this, in this case, I actually have to subtract. I have to do 100 minus 40, and I get 60. So we'll be doing a lot of work with angle addition. These angles, called vertical angles, are extremely important. We will see those throughout the duration of the entire year. So it's really important to get familiar with vertical angles. So I like to call them, my little slang term for them is opposing V's. What that means is if you have two crisscrossing lines or segments, whatever, if we look here, they make the letter V, both above and below. So I can go ahead and say angle 2 is vertical to angle 4. And if that's the case, they are always congruent. So angle 1 and angle 3 are vertical and congruent. And there we have a little note. The last word we need to talk about is adjacent. Adjacent angles are angles that just share a common side, but have no common interior points. So that just means that they wouldn't overlap each other. So if I look here at angle HIK and angle KIJ, those two angles fit right against each other. There's no gap in between them. So I would say they're adjacent. They both have this common side, but they don't overlap each other. So what would non-adjacent look like? Well, we'll name this EORT. I would not say, for example, that angle POR is adjacent to angle POT because they overlap each other. So it's not that they fit comfortably side by side. One bigger one overlaps the smaller one. So R is a common interior point. We don't want that. I could say angle POR and angle TOR are adjacent because they are right snug against each other. So that's what adjacent angles mean when we're talking about those. And then we were just kind of refreshing these words. Probably have heard of them before at some point. The word complementary means angles that add to make 90 degrees. The word supplementary means angles that add to make 180 degrees. So in this case, angle UST and angle USV are supplementary because if I were to travel from U to V, so I travel that first angle, and I travel then from U to T, I really just traveled half of a circle. I traveled 180 degrees. So I would say that they are supplementary. Another way of saying this is I could say angle TSU is the supplement of angle USV. When you say is the supplement, that just means combines to make 180. So if I asked you, what's the supplement of 150 degrees? We would say 30. Does 30 and 150 make 180? It'd be the same thing for complement. If I asked you, what is the complement of 40 degrees? You would say 50, because 40 and 50 make 90. So if angle TSU is 120 degrees, then angle USV has to be 60 degrees, again, because they are a linear pair. They make a straight line, they make 180. So we're going to do one practice problem, and we're going to take our information, and what we're going to do is start putting our information in the picture so it makes visual sense to us. Angle HOK has a measure of 4x minus 6 degrees. So it's some mystery number we don't know. Instead of writing out the actual number, they gave us an expression, which is fine. We can work with that. And angle KOB is 6x plus 2 degrees. Again, it could be 110, it could be 150. We have no clue. All they did was give us an expression that represents the measure of the angle. So they're telling us to figure out, first off, what x is, and then use that to figure out the measure of angle HOK. So when I look at these two angles, if I look at HOK and KOB, I realize when I put them together, I make a straight line. I make 180 degrees. Again, if I travel from H to K, that I just traveled the measure of angle HOK. And if I travel from K to B, I've traveled angle KOB. So I've really traveled a total of 180. So it would make sense to add these together. And set it equal to 180. So again, I'm taking one expression that represents a measure plus another expression that represents a measure, and I'm just adding them together and setting it equal to 180. So I'm going to go through and combine my like terms. And 4 plus 6 makes 10. Negative 6 and positive 2 make negative 4. Again, we add 4 to both sides. So I will get that x equals 18.4, which is fine. Now that I know what my x value is, I can go back and answer the question and solve for angle HOK. Now, since it was 4x minus 6, instead of x, we can now plug in 18.4. And then I would have to simplify that expression, which means we'll need a calculator. So about 112.4 degrees would be angle KOB. If I wanted the HOK, which is what we were looking for, should get 67.6 degrees. And if you want to double check those, you can always add them back together and make sure you do indeed get 180. So we'll be doing a lot more work with that, but for right now, we have a little bit of an introduction and we have a little bit of problem-solving strategies under our belts.